Thank you. That's the most awesome intro I've ever had, actually. Awesome. All right. Hopefully I actually live up to it. Cool. Well, thanks for showing up here to the talk right before lunch. The good news is if this talk is bad, you're able to leave early and get to lunch ahead of all the lines starting. So either way, you win. So should be fun. Cool. All right. Let me give you a quick background and let's jump in. My background, so I come from the security side. I've spent my entire career on the security side of the fence. I'm curious actually for the audience in here, if I can see, how many, are any folks in here in like a full-time security role where your full job is security? Yeah, awesome, okay. I can sort of see some folks, awesome. Cool, okay. So my own background, I started out in security consulting and what's called pen testing. So companies hire us to find vulnerabilities in their infrastructure, in their applications, or anything like that. Did that for a really long time, and then got what turned out to be an incredibly unique opportunity, which was to go be the first head of security at a company called Etsy. And at the time, this was almost 10 years ago. For this audience, I don't really need to give much of a background of who Etsy was, but it was really interesting because, I mean, it was basically Netflix on the west coast of the US and Etsy on the east coast of the US that were pioneering this crazy thing that became known as DevOps and the shift to cloud. Along that journey, we needed to find better ways to defend our web applications and our APIs and everything there. So we built some cool technology in-house, and then myself and my two co-founders left Etsy and turned that into a product. So that's Signal Sciences, which is a modern web app firewall that's built for DevOps, built for cloud, and a bunch of the DevOps leaders use us to defend their apps and APIs. That's not what this talk is about. That's the end of the intro, and that's actually the last thing you'll hear me say about Signal Sciences. This talk is about a bunch of the things that a bunch of the lessons that I had to learn very painfully that I wish, this talk is basically what I wish I could have given myself on day one of going through a DevOps transformation and thinking about how to best defend our applications and our APIs, and how do we adapt the historic controls that were built for a data center waterfall era, how do we adapt those for the DevOps world and cloud world? So I'm going to give you the conclusion right up front. Really, if there's one thing that I hope you take from this talk, it's really this. It's that security shifts from being a gatekeeper who basically says no to everything and tries to block everything. It has to shift to enabling teams to be secure by default and enabling them to move at the speed they want to move. That's really the theme of everything you're going to hear in this talk. So what has changed? This is a DevOps audience. Usually I speak to a lot of security audiences, and I still have to kind of explain to them what DevOps even is as an idea. I don't need to do that here. I'll just give you one example, which is for plenty of us, the shift can be very abrupt, right? I think for some lucky folks, when you start out in a startup that's doing kind of DevOps and CI/CD and is in the cloud from day one, that's great. You don't have a lot of legacy to deal with. I think for most of us, it's more about adapting an organization to that. So on my own example there, actually, my last security consulting project was with a big US healthcare company where they would change their production applications. They would make deployments once every 18 months. So when you'd come in and you'd find a critical security vulnerability on the front page, they'd say, that's great, we'll fix that in 1.5 to 3 years. And that was absolutely terrifying. And I left that project on a Friday, finished it up. I took no time off because I'm an idiot, and started Monday morning at Etsy in almost 10 years ago, and they sat me down and said, we make production deployments 20 times a day, figure out security, go. So I went to the nearest bar as fast as possible and tried to get as much whiskey as possible, because at the time that really seemed like an impossible task. And many things change out of this shift. So this talk is going to be about how some of the technical controls shift. But really the bigger picture here is how the culture has to shift and how security teams interact with the business has to shift. So that's actually what this talk is up here. And actually just released a book on this as well on O'Reilly. So if you want to email me, I'm happy to send you a copy of the book or the slide decks or anything like that. For today, the biggest theme is really that security can no longer be kind of outsourced to as a specialized group where it has to review all of the code and review all of the infrastructure changes and all of these things, because the reality is it can't actually keep up, right? One of the whole themes of DevOps is the increase in velocity and the ability to make change. And so security is always going to be a much smaller group than engineering or DevOps. And so it can't like sign off on every change anymore like it tried to do in the waterfall era and the data center era. So security's focus really fundamentally shifts to making development teams and DevOps teams security self-sufficient. Like that is it changes the entire way we build security programs, because now you're going from acting as a gatekeeper to giving these teams the tools and techniques to do security on their own. And really, it only becomes successful if it can actually bake into the development and DevOps process. I'll give you a good example of this going wrong, which is I was having coffee with a Fortune 500 huge company CISO a few months ago, and that CISO said, "Oh yeah, I was asking them about what's their plan around cloud, what's their plan around DevOps," and they said, "Oh yeah, no, I'm not going to allow that here. That whole DevOps thing, that whole cloud thing, it's not secure. I've told all of our executives, no, we're not allowed to do that." It's like, okay, that's a bold choice. And I got coffee with the CIO and the CTO immediately afterwards. And I was like, hey, tell me your version on kind of how you're thinking about cloud and DevOps. And they said, oh yeah, we've got 20 apps in the cloud already. We're going to have 50 by the end of the year, and we're going to have a couple hundred next year and a couple thousand after that. And I kind of looked at them weird, and they're like, oh yeah, you met with the CISO. Yeah, we just don't tell the CISO anymore, because all they do is say no. So they go sit at the kids' table, and we sit at the adults' table and make actual decisions for the business. Because if all they're going to do is say no, we're not going to listen to them anymore. And I think this is the perfect example of what happens if security doesn't change its approach, right? If it keeps kind of with this approach of saying no to everything, the business isn't going to stop, right? DevOps teams aren't going to say like, oh, well, I guess we just get to go on vacation for 8 months. Like, no, you're going to go get your job done, and you're going to go build new infrastructure and new applications. So I included a highly technical flowchart here of what this looks like in that sort of situation. So this would be the CISO and the security train plowing into the DevOps car while shouting about safety. Which I think sums up security perfectly in a lot of places. Okay, so let's get into, this is kind of the agenda for the talk. Let's get into, so these are kind of core components of really for any organization what some of their security program looks like. So you do some sort of training, some sort of threat modeling or thinking about threats, and then you do kind of design review and static analysis in these. How people do this is different inside each organization, but this as a high-level view is fairly similar. So what of these needs to actually adapt the most? So these are the ones in bold. These are the ones that I'm going to talk about today. So all of these things actually change, but this is a 40-minute time slot. So we're going to be rushed just to get through these, and that's why I didn't include the others. But if you're interested in those, happy to either do a question afterwards, or we can follow up and talk on more of that. Okay, so first moving into static analysis. So static analysis has historically been, something that you run on your application. It spits out a 10,000 page report, 9,999 pages of which are false positives, and then you try to actually do something with that. So this is going to be kind of the format for each of these sections. I'm going to talk about how we've used this in the waterfall era, and then how we actually adapt it to the DevOps, cloud, fast kind of CI/CD area. So this was historically a really heavyweight process. How many folks have worked with, had any sort of static analysis in their build pipeline or development process or anything like that? Yeah, awesome. Okay, so you know what I'm talking about. This has been really heavyweight. Basically, you'd go turn on static analysis. And I don't mean linting, I mean like full static analysis. And you'd run it over your code base, and it would take hours, days, weeks to run. And then at the end of that, it would spit out a huge report. And typically what security people would do is they'd run the security static analysis tool. It would spit out a huge report. They'd forward that to the development lead or the DevOps lead and say, hey, it's your problem now. Go figure it out. And the development lead would take a look at the report and see that the first 20 issues in that report were all false positives and not real. And then what they would do is they would flag any email that came from security as spam and say, stop sending me useless issues. And so this is basically the world that we've lived in for static analysis for the last 10 years, 15 years. the funny thing is, like, these kind of slow, big scans, ignoring the false positive bit for a second, but these slow, big scans, these were kind of acceptable-ish in the waterfall era, where you had plenty of time for each release cycle. If you think about if you're releasing every 18 months or even every 6 months, you've got plenty of time between each release. Their static analysis tool taking 3 days to run, it's not that big of a deal. But how do we actually adapt this? So I'm going to give kind of the methodology, I'm going to give an example, and then I'm going to give 2 examples of how we can actually repurpose static analysis and use it in kind of a really clever way to give some interesting coverage. So the methodology first is that basically we go from being a really heavyweight top-down model of scanning everything to a very lightweight bottoms-up model to only scan for certain things and then add more slowly over time. So rather than say, let's scan the code base for every possible type of vulnerability, what you do is, hey, let's scan the code base for one type of vulnerability, and only one that we think it's going to very reliably detect. And then as we confirm that, hey, only real issues come out from this, it's not slowing things down, it can run in Jenkins or any sort of CI pipeline and be fast enough, okay, now let's add a second, now let's add a third, now let's add a fourth. And this really is about showing that something that used to be a very slow and very false positive filled control can actually run at the speed that your DevOps teams and development teams are trying to do, and that it can ultimately, it needs to be able to run on every code commit. That's basically the long and short of it. So I'll give you an example. Typically static analysis would start with these huge, heavy problems of data flow analysis and all the tracking there to try to find SQL injection and these sort of issues. Like, forget that. Start with the most basic things like command execution, where you're just basically looking to see if the code base calls system or eval or these sort of basic functions. And if this sounds a lot like grep, you're completely right. Basically, you start with grep. In fact, that's what we actually did back at Etsy even, is none of the commercial static analysis tools were any good. And so we basically built security-focused greps into our build pipeline because it was fast enough and it wasn't triggering false positives. And so then you build up and you add additional checks. You might start with command execution, then you go to SQL injection, then you go to cross-site scripting. You add these on. But the point is, don't start for everything at once because it'll be slow and it'll be full of false positives. Start small and build up and be focused on speed. Okay. 2 other ways that we can actually use static analysis in a totally different way. So number 1, we used to use static analysis as a way of enforcing policy as well. So we would say, okay, old bad encryption or hashing, like say MD5, for example. It's a broken hash algorithm. It's dangerous to use in your code base. So the old way we do this in static analysis is to say, run over the code base and file like a blocking bug or a blocking ticket if a developer used MD5 and break the build or block the build until they fix that. Now, that's not wrong. You don't want to allow old hashing functions and things like that in there, but we're actually missing a really unique opportunity here, which is when certain things that indicate sensitive functionality start appearing. So when hashing or encryption or dealing with the file system of the server or anything like that start to appear in the code base, this actually becomes a really strong flag to drive a more in-depth review. So what you can actually do with any sort of static analysis, doesn't have to be commercial, can be totally open source and basically just grep, is when you see these sort of patterns start to appear, encryption, hashing, file system operations, use that to send off a flag to, it can be the security team, it can be a development lead or a DevOps lead or an architect or anything there, and say, hey, there's some inherently sensitive things going on here. Take a closer look, have a conversation with the team. When we first tried doing this, we thought, maybe it might be useful, it might not be. It led to some huge discoveries actually, where we saw not MD5, but modern like SHA-256 come into the code base. We said, that's weird. Like that team is doing a bunch of hashing, but we don't know what they're working on. So we went over and we talked to the team and they said, oh yeah, we're building a new API service that's going to collect all of this new user data that we as the security team knew nothing about. and we want to protect that data, so we're going to hash it. And we're like, oh, wow, okay, first of all, super glad that we now know this is happening. And number two, actually, you're not really looking for hashing here, you're looking for encryption, and here's a whole API service we've already built for that. So now you don't even need to manage the keys, you don't need to deal with any of the hard parts. And so we were able to give them that service. It made their lives easier, and it made our lives easier because we found out about this before a press release went out, which is how security teams find out about a lot of functionality. Okay, the second and last kind of way we can use static analysis, or at least that I talk about here. So another interesting, it's kind of a different take on that previous idea, which is knowing when, rather than sensitive types of code, knowing when sensitive areas of code start to modify. So every app, large and small, has this sort of stuff where typically when the app was first written, someone senior implemented the role-based access control bit or the core business logic of it, or things like, or kind of the authentication and authorization portion. And that sort of code, typically you write in the beginning and then you almost never modify, right? The entire app is just built on top of that. So in an old security model, what I would see organizations try to do is they would say, okay, if anyone tries to change any of those parts of the code base, you need sign off from 5 different people, and the code is blocked from being committed until all these different people sign off on it and everything like that. And so nobody can change that part of the code base until it happens. The problem if you try to do a control like that in a DevOps world is, hey, it's rare, but those parts of the application do need to change sometimes. And most often it's when you're working in the middle of an outage or an incident and your SREs are frantically trying to get the services back up and they need to change some certain key component. And if they're, in the middle, it's 3 in the morning, the service is down, a bunch of SREs have been paged, and they're trying to make a change that might bring the site back up, and a security control says, no, 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 you need to get 5 people to sign off. First of all, you're gonna have a very bad morning the next day as a security team. And number two, every control like that is going to get ripped out the next day, right? Because it impeded the ability for people to restore the service and do their job. And so the way that when we step back and think about, okay, what's the problem we're trying to solve? Well, basically, we don't need to block that change. We just need to know about it. And so what you can actually do is a really effective control. And this, a lot of people tried a bunch of different things, but this is really the strategy I've seen most of the DevOps leaders kind of converge on is you allow changes to happen there, but when someone is trying to check in code to that sensitive part of the code base, it sends them back a message that says, hey, this is a sensitive part of the code base. Not sure if you actually meant to change this. It is going to page these 3 people or these 5 people if you commit this code. And that might be your CTO or your chief architect or your CISO or anything like that. And the good thing is, if there's an SRE working in the middle of an outage, and they say, yeah, absolutely page those people. They already have been paged because there's an outage. And it allows them to move forward and fix the issue. If it's a brand new junior developer who doesn't realize they're working on the main master branch of the code base and thought they were just messing around on something, they're going to back that change out really quick, because being an intern that pages the CTO at 2 a.m. about messing with the wrong part of the code base is generally not good for your career. So it gives you that coverage without sacrificing speed, which I think makes for the perfect example of how we have to modernize security controls for the DevOps world. Okay, moving on to dynamic scanning. And static analysis was by far the longest portion. Dynamic scanning is actually pretty quick. This meme has no relation to dynamic scanning. If you can find a better meme for dynamic scanning, you are a way better speaker than I am, so please send it to me. All right, so we used to use dynamic scanning, and this, when I talk about dynamic scanning, I mean commercial tools like AppScan and Web Inspect and things like that. Things that would try to crawl the application, get to every page, try to inject different types of input to find security vulnerabilities. And basically, we use this kind of as a cheap way of trying to do pen testing to say, well, if a scanner can find it, we should fix it. So how do we actually adapt this? The problem with this control is all of the scanning technology was really built for the web apps of the early to mid 2000s when they were very linear, and it went from page 1 to page 2 to page 3. And you could either had very specific form fields that you could inject input into and everything like that. You go look at a modern application, and it's mostly a ton of API calls and web services, or a single page JavaScript app or anything like that. I mean, if you look at a 2002 web app and a 2019 web app, they look very different. Or get new designers if they don't. I don't know. But Scanners didn't really adapt their technology. So this is something I've spoken with a bunch of other CISOs on this, and basically all of us have said the same thing, which is we all spent close to a year trying to make these sort of scanners work in a DevOps environment, and almost all of us just walked away at the end. I'm not saying it's impossible. You may use them to great effect in your organization. I'm saying for most places, you've got a million security projects to do, and mostly what I've seen is it's better to focus on other areas. But there's actually two things that you can use scanners for that are really cheap and really effective, actually. So number one is crawling your app as much as possible to determine and ensure that security policies are actually being enforced. So I'll give you a couple examples. Number one would be, hey, for this app, we want to enforce that it's always served over TLS or SSL. Okay, great. Well, as we all know in web operations, you might make that change. It'll work for 98% of the app, and then there's all these little corner cases where it doesn't inherit the framework correctly or the load balancer config or something like that. And so dynamic scanners can actually be really effective at this, of scanning continuously and saying, whoa, 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 I just found a page in the app that was served over plain text HTTP and not over TLS. So they're good for that, and you can just bake that basically into CI and just have it run continuously. Another is, and this one's going to seem dumb at first. In fact, I probably would have made fun of this if this didn't happen to us, and it's totally saved us, which is a control on telling you when previously fixed vulnerabilities show back up in the code base. So like, let's say you have, let's take a super classic vulnerability, like a cross-site scripting issue in the search box. And so someone inserts JavaScript in there and it echoes back to them. And you fix that, that issue gets discovered, you fix it, and you say, great, we fixed that issue, it'll never happen again. For anyone who's done software development, bugs show back up in code base all the time. So dynamic scanners can be really effective where you tell them very specifically, hey, there was this type of vulnerability in this exact spot of the app. So it's not having to crawl and figure that out. But you tell it, hey, go try to put script alert in the search field every time there's a new build. And if that ever succeeds, now you know two things. Number one, that issue showed back up. And number two, that somewhere else your tests are actually failing. Okay, let me start to move a little quicker because we got 15 minutes left. All right, security visibility. So security visibility, how we've had this in the past. The short version is we basically haven't had security visibility in the past. We had different sources of information that were all very siloed in the organization. So logs might go to the ops team, customer service reports about strange things happening with the app might go to customer support, outages or things that look like outages might go to dev teams, but all this data was completely siloed. So how do we actually adapt this? This is where security, this is where they need to learn the lesson of kind of the broader DevOps movement, which is it's about bringing visibility and bringing previously siloed capabilities to the rest of the organization. So, taking development capabilities, taking operations capabilities, and making them usable by both sides of the house. Same thing on the security side. So I'll give you an example here, which is HTTP 500 errors, so just generic errors that happened in a web app or an API or something like that. We ran an experiment where we went and talked to a bunch of different teams inside the organization, and we said, what does this graph imply to you? Like, what do you think this means? And so you'd ask a development team this, and they'd say, oh, well, we had a new developer show up this week, so they probably just made a bad code deploy and then they fixed it and everything was fine. We asked the DevOps team what that meant, and they said, it's probably that dev team over there. They paged me 4 times this week, and I'm not going to listen to any more pages that come from there unless they're a Sev1 issue. I asked part of my security team, hey, what do you think this implies? They said, oh, that's interesting. I wonder if that's somebody discovering a vulnerability and figuring out how to make a working exploit for it and breaking the app until they figured out how to make a working exploit and then actually succeeding. And if you're ever fortunate enough to ask your attackers, a lot of times you'll hear, oh yeah, I was super noisy trying to figure out how to make a working exploit before I actually got it working. And so the interesting thing out of that is when every group looks at one bit of data and draws different conclusions, it means everybody is missing context here. And so what we really learned out of that is we need to bring kind of DevOps relative data, relevant data, and development relative data and all this combined with security relevant data so that any one of those groups could take a look and say, wait a minute, why is the errors graph spiking at the same time that we're seeing more attacks than we've ever seen? Now anyone can look at that and say, wait a minute, is this an attacker actually discovering something? And start to triage as a result. All right, moving on to feedback. Office Space is now 20 years old, so I'm allowed to put these slides back in slide decks now. It's crazy. Feedback used to be done as annual pen tests. So how many folks have hired or lived through some sort of annual pen test, right? Like you had security testing. Typically they come in once a year, right? And it's typically a couple people for a couple weeks. And the problem is this really only answers the question, do I have bugs? And the answer to that is always yes. It's software development, it's infrastructure. We're always going to have bugs. But when the application was only released once a year, this was kind of real time enough. So how do we actually adapt this? This is about the, if I had more time, I'd spend probably 20 minutes just on this. But this is more about the combination of bug bounties and pen tests. So bug bounties, just to get everyone on the same page, bug bounties are where you put out basically a statement or an SLA that says to security researchers out there, if they discover any sort of vulnerabilities in your service or your infrastructure, here's how they can report those to you. And if they act in good faith and they play by your rules, you will reward them in some way. Now that might be money, it might be sending them a t-shirt, it might be sending them a beer, it might just be saying thank you. The level of rewards can totally be different. But the point of this is that it used to be that if you discovered a vulnerability in a system and you reported it to that company, you had 50-50 odds of getting sued and taken to court or getting arrested. And so what it incentivized then was that researchers would just publish vulnerabilities anonymously, and then teams would have to scramble to go fix those issues. And it was a lose-lose for both sides. So bounties came about as a way to say, hey, let's turn this into a system that can actually reward good behavior and get a way to have bugs submitted. Now, this is really good because obviously all of that, but also it enables more real-time feedback because bounties go on all the time. You know, it's happening all day, every day. And so it frees up your pen test so that you can use those once a year on a very focused spot that you're super worried about, you know, maybe a new service or maybe a super legacy app, something like that. And bounties can become a good way to get more general real-time feedback all the time. So I get to talk to a lot of different organizations, and out of my own learnings at Etsy and then a bunch of the kind of DevOps companies, this is really the commonality of what people that are embracing security successfully, this is what they really start to focus on is how do they get that continuous feedback loop, and how do they really get visibility so that development teams, DevOps teams, and security teams can actually see what's going on with their services and seeing where they're being attacked and where they're being abused. The way to think about this is really, if you want to be successful against real attackers, you need to be able to answer the question, how do I know when my attackers are being successful themselves? And when you start to think about this, this is a question not many of us are actually able to answer today. And that's good. It gives us the starting point of how to actually think about it. So a lot of security slides and talks are all doom and gloom about why everything is terrible and why DevOps is less secure and wrong, things like that. So I want to spend just a couple closing slides on why embracing DevOps can actually make us more secure. So there's 3 points on this and then some closing slides. Number one is that the whole kind of shift to DevOps means we tend to invest in visibility more. We give our DevOps teams more visibility. We give our development teams more visibility, our security teams more visibility. And this allows us to detect our attackers earlier and earlier than we could in the past. Historically, most organizations find out that they've had a security breach because a newspaper or a reporter calls them for comment because they're about to publish a story that they've been breached. And that's the way that they find out. And this is not good. We can do better. And so starting to think about visibility, it really gives us the ability to detect people earlier and earlier. Number two is that as we embrace more DevOps concepts, things like game days and kind of the chaos monkey approach and things like that, it's things where we start to test our systems. We test for failures before that failure actually happens in the real world. And so this means that we can, from the security side, we can start to incorporate security testing in there as well that says, hey, for that particular bit of infrastructure, what would we do if a critical vulnerability was found? How would we update it? How would we fix it? How would we make a deploy or spin up new infrastructure? And the real beauty of DevOps is that for the first time, we can actually move faster than our attackers. If you think about the waterfall era and where you find a critical issue in that, and it would take 18 months or 3 years to actually fix, in DevOps world, if you're deploying every day, well, and you've got to fix a critical issue, you just do another deploy that day. It's not It's not that crazy. And then number 3 is it really gives us the ability to continuously test your security operations processes and things like that. So you can start to run really good scenarios to say, hey, if this vulnerability that we just found either via bug bounty or via a pen test or something like that, what would have happened if an attacker found it? How would we have known that they had discovered it? How would we have known that they were starting to exploit it? And how would we know that they were starting to steal data before they got to steal everything? And then you start to ask yourself more and more questions there. And to be totally honest, you won't like the answers at first because your answers won't be that good. I know ours certainly weren't. But it gave us a really guiding philosophy to start to think about, OK, what would we have to do to be able to answer these questions? And this is a whole topic in and of itself. But it really starts to guide where you invest and think about security. So I'll give you an example of moving forward a bit from there, how things can actually go right. So this was an example from, it's still public up on Reddit as far as I know, from years and years ago, where we had started to ask ourselves those questions and really started to invest in thinking about how would we know if an attacker had discovered a vulnerability. And we had some alerts that we had built go off suddenly one day late on Friday. Where an attacker discovered a vulnerability. We knew they were human. It wasn't automated because we could see them trying different attack payloads, and they typoed some of them and everything like that. And they discovered a vulnerability. They figured out how to make a working exploit for it, and then they stopped. And they went away, and we're like, OK. So we emailed their Etsy account, and we said, hey, hi there. We see you. And here's a contact address to let us know about the vulnerability if you want to let us know. And then we pushed a fix for that issue before they actually reported anything to us. So they came back a few hours later. I think they had gone out to dinner or something. And they came back a few hours later, and they had written up a whole really nice email for us documenting the issue. They turned out to be a really great researcher. But they emailed us, and right before they emailed us, they went to test it one final time, and it wasn't working. And they tested and tested again, and it wasn't working anymore. And so they sent the email, and they're like, hey, this was the email I was going to send you. But my vulnerability isn't working anymore, and I can't imagine that's a coincidence. So a couple things. Number one, I wanted to give you the details here and share that I wasn't an attacker. I'm not a bad person. I wanted to share this. And then number two, I was actually doing all of my testing from my home IP address, so please don't arrest me. And so we actually got to have this really fun back and forth with the researcher, and they ended up sharing a bunch of other good results with us. The reason I share this story is not because, oh, we were so smart, like it was so cool. It had nothing to do with that. This was really a very strong defining moment for us on recognizing that asking ourselves these sort of questions and starting to think about visibility and how do we detect when our attackers are being successful, it really paid off. Because at the time, we weren't sure if that was going to be useful or we were wasting time and money. So, all right, wrapping it up so we got time for questions. Really, it kind of boils down to this, is that security has mostly focused on very slow gatekeeping controls that have tried to discover all of the bugs before something goes to production, and they don't want to sign off on it if they can't feel like they've done all of this testing. The reality of DevOps is stuff's going to go to production all the time. Right? It's happening all the time. And so security needs to shift its mindset and start to think about, OK, yeah, we want to scan for bugs, and we don't stop trying to do that, but we don't block it and say no anymore. What we really want to focus on is how do we enable visibility and feedback and bring that directly to the development and DevOps teams so that ultimately we can make them self-sufficient. So you're awesome for sitting through a talk through lunch. Thank you for coming.